Welcome to Math with Professor V. Here is your latest integral of the day as part of our countdown to 2025, 13 integrals in 13 days. This one's pretty mild, so hopefully you guys just enjoy working through it without too much stress. We have indefinite integral of secant to the 6th theta over tan squared theta d theta. So go ahead, pause it if you'd like. You only need really one integration technique and you'll be on your way. So what I did was break up the numerator, and anytime you have tangents and secants, usually you're gonna do some sort of u sub and play around with trig identities and whatnot. So I wrote the numerator as secant to the 4th theta times secant squared theta d theta, and then down here I have tan squared theta. So I'm kind of hoping that this secant squared that I just plucked off, secant squared d theta, can get absorbed and become du when I make a u substitution. So in order for that to work, I would need to, let's think backwards, let u be tangent theta, right? And then du would be secant squared theta d theta, and that would work out just lovely. So then this denominator is already good to go. That would be u squared. However, I need to rewrite secant to the 4th theta all in terms of tangent. Can I do it? Absolutely. So secant to the 4th theta, remember that's secant squared theta squared, and I can replace secant squared theta with tangent squared theta plus 1. So then I would have that entire quantity squared. So let me rewrite that first, and then we can go ahead and do the u sub. Notice your trig is just so essential. You gotta remember it all throughout your math career. Tan squared theta plus 1 squared. Let me put this lovely secant squared theta d theta all up top here, and then tan squared theta still in the denominator. So now let's go ahead, make this u sub, and rewrite the entire integral in terms of u. In the numerator, tan squared theta plus 1 squared is going to be u squared plus 1 quantity squared. And then secant squared theta d theta is just du. Boom. Beautiful. And then tan squared theta in the denominator, that's simply u squared down there. Okay, looks nice, looks nice. What to do? From here, I would just multiply out the numerator, and then we can simplify the integrand without too much stress. So this is u to the 4th plus 2u squared plus 1, all divided by u squared du. And then now simplify, break up each of the terms in the numerator, and write it over the denominator separately. I'm just going to simplify as I do that. I think you guys can handle it. This is going to be u squared plus u plus 1 over u squared, which was u to the negative 2nd du. And then from here, we're ready to go. We can take the antiderivative of each of the terms pretty painlessly. So this is 1/3 u cubed plus 2u. Antiderivative of u to the negative 2nd is going to be negative u to the negative 1st, so I'm going to write it as negative 1 over u, and then now it's time to put plus c, and then just go back, replace all of the u's with tan theta, and we're done. So 1/3 tan cubed theta plus 2 tan theta minus 1 over tangent theta is cotangent theta, so let's write it like that, plus c. And we are done. Okay, now let me know if you solved it differently. You could probably play around, rewrite everything in terms of sines and cosines, and then maybe make a sort of similar substitution or whatnot. I usually will do that if I get stuck, or if the trig functions aren't ones whose derivatives involve one another. So like if it's not tangents and secants, or if it's not sines and cosines, then I'll go back and rewrite it. But tangent and secant usually work out very well together, so I tend to keep them when I can. Okay, that's it. So don't forget to give the video a thumbs up. Subscribe to my channel if you haven't already. If you need to brush up on any integration techniques, then check out the videos that are linked in the description. They're all on the Calculus 2 video lectures playlist. Feel free to just blaze through the integral of the day playlist. Solve them on your own and then watch me solve them. It'll make you an integrating beast. Let me tell you. And thank you guys so much for your support. I hope you're enjoying the series. I see from all your comments that you are, so thank you. And comment, let me know which was your favorite integral so far. I think some of you guys have made requests for what you'd like to see in the next couple of videos, so I'll do my best to accommodate. And I will be back tomorrow. All right. Love you all. Thanks so much. Bye.